Assalamu alaikum and good evening, everyone. Today we are going to start May-June 2023 paper 5-2. Question number 1. 3 students are asked to prepare samples of benzoic acid from the alkaline hydrolysis of methyl benzoate. Sodium benzoate is the salt form, which is then acidified with hydrochloric acid to form benzoic acid. So see, it's the hydrolysis reaction. See, it's an ester, methyl benzoate, right? And initially on alkaline hydrolysis, we got an alcohol, and as I have told you that with the alkaline hydrolysis, we get the salt. Then after adding the acid, it turns into benzoic acid, right? So it's a benzoic acid over here. Yeah, is this understandable to all of you? Now, okay, the student uses the following method. You have to follow the method. You have to keep the steps of the methods in mind. And if you forget anything, whenever there is something asking the question, again go through the method, because mostly the answer is in, method. Step 1, put 1.242 gram of liquid methyl benzoate into a 50 centimeter cube round bottom flask. Okay. Prepare 100 centimeter cube of 1 mole per dm cube aqueous sodium hydroxide. Okay. So that is the mass of benzoic acid we have. This is the volume of NaOH we have made, and this is the concentration of NaOH. At 10 centimeter cube, an excess of prepared NaOH to the round bottom flask. So see this one, that 100 centimeter cube is prepared, and out of that 100 centimeter cube, we have used 10 centimeter cube initially, right? Add some anti-bumping granules to the round bottom flask. It is because when we heat it, so the liquid starts to boil and, splash. So anti-bumping granules, control that splashing of the liquid. Number 5, fit a condenser to make a reflex apparatus. Reflex reaction mixture for 20 minutes. So whenever we are doing reflex, the condenser is actually, if you recall, for a reflex, the condenser is placed in this displacement. The vertical displacement of the condenser is there for, reflex. Allow the reaction mixture to cool and carefully pour the liquid into the beaker. Acidify the liquid with dilute hydrochloric acid. Filter the mixture formed in step 7. Okay. Purify benzoic acid by recrystallization from hot water. Filter, dry, and record the mass of pure benzoic acid obtained. Calculate the volume of methyl benzoate used in step 1. Give your answer to the nearest 0.05 centimeter cube. Okay. All the steps are clear to all of you. If any one of you has any confusion, please let me know. In step 5, what you are asking, MBA. Where is MBA written? In step. Okay, I'm saying it's a mass of benzoic acid. B in the subscript. Okay. So you have to calculate the volume of methyl benzoate, and they have given you the density of methyl benzoate, right? So you know that the formula of density is mass over volume, right? So density is 1.08. Mass that we have used for a benzoic as methyl benzoate. Sorry, it's not benzoic acid, it's methyl benzoate. My bad. So the mass of methyl benzoate is 1.242, and there is a volume. So volume is equals to 1.242 over 1.08. Can anyone calculate it and tell me the answer? Okay, thank you, Hussein. So it's going to be 1.15 centimeter cube. Is this understandable to all of you? Now, identify a suitable piece of apparatus to measure the volume of methyl benzoate required in step 1. Okay. So, see. Here, if you see, sodium hydroxide is in excess, right? So, if it's an excess, it means that if its volume is not accurate, then it doesn't matter. So remember, for any substance which is in excess, we measure its volume using measuring cylinder. Is this understandable to all of you? And if it is in excess, it makes the, liquid methyl benzene a limiting reactant. And if it's a limiting reactant, then its volume must be measured accurately. And to accurately measure its volume, that we have found how many volume we needed, 1.15 centimeter cube. So for 1.15 centimeter cube, we need a burette to measure 1.15 centimeter cube. Is this understandable to all of you? Because if we talk about pipette is also for accurate measurement, but pipette can only measure a fixed volume like 25 centimeter cube. Or if the pipette is, for example, of 10 centimeter cube, so it can measure only 10 centimeter cube. So burette can be used to measure the 1.15 centimeter cube volume accurately. Is this clear to all of you? Okay. Now, calculate the mass of sodium hydroxide that is needed to prepare the solution in step 2. Okay, so we have to see in step 2 what volume we have prepared. Volume that is prepared is 100 centimeter cube, and the concentration that we need is 1.00 mole per dm cube, right? So from this we can, yeah, I am asking about, sorry. Here we have written down the volume, and so we have to write the apparatus. I'm telling you the apparatus, but I wrote 1.15. Thank you, Mahveen, and thank you, Mariam. Okay, clear? Is this clear? Okay, now we got the volume, we got the concentration. So by the help of the formula, concentration is equals to moles upon volume. So the concentration is 1.00. We don't know the moles, but we know the volume, that is 100 centimeter cube, that must be converted into decimeter cube by dividing it 1000. So I'm going to get the value of X, which is going to be 1.00 times 0.1. So I got the moles that 0.1 mole of sodium hydroxide are needed, right? So if I know the moles, so I can calculate the mass. That mass is equals to moles times MR, right? So the moles of sodium are 0.1, and the MR is the sodium. It's going to be 40 NaOH. So if you multiply it, 0.1 times 40 gives you 4.0. So we need a 4 gram of sodium hydroxide and then dissolve in 100 centimeter cube of water to make this the solution that is prepared have a concentration of 1 mole per dm cube. Is this understandable? Yes, see, it is given, okay? Otherwise, they have given you the MR over the AR of the elements over here in the question. B. Student 1 added the mass of sodium hydroxide calculated in A3 into the beaker. Describe the steps the student should take to make 100 centimeter cube of 1 mole per dm cube NaOH. Give the name and the capacity of any apparatus that should be used. You write your answer using a series of numbered steps. So, okay. It has added the mass into the beaker. Is my voice is still lagging? Okay. So what we are going to do? Next, after this, dissolve the solid in a small amount of distilled water. Okay. After this, what we will do? Transfer this solution and washings in 100 centimeter cube. And whenever we need to prepare the solution, we need a volumetric flask, right? Into a volumetric 100 centimeter cube volumetric flask. Okay. After this, fill the volumetric flask up to the mark with distilled water and mix it. See, student 2 prepared 0.1 mole per dm cube. Is all the steps clear to all of you? 0.1 mole per dm cube sodium hydroxide instead of 1 mole per dm cube in step 2. State how this would affect the final mass of benzoic acid formed. Explain using calculation how you come to conclusion. Okay. So we have to identify the effect on mass, that how final mass of benzoic acid formed. No, it will going to affect Hussein. See why? Because initially we are using the NaOH has this much concentration and we are using its 10.0 centimeter cube volume, right? Is this understandable? Yes, is this understandable to all of you? Now see, the student prepared this much volume, this much concentration. So see, its, concentration is 10 times lesser. The student made the solution has the concentration 10 times lesser than the concentration that we need. Is this understandable to all of you? Yes. And it's how much volume we are going to use? Obviously, we are going to use this much volume. So this makes it a limiting reactant in its moles. Actually, when it is actually by mistake gets diluted 10 times. Yes, so we would get the lesser mass of the final mass of benzoic acid, because the mass of now in this solution, the mass of sodium hydroxide, the moles of sodium hydroxide actually gets lesser than the methyl benzoate. because its volume, its concentration is decreased 10 times, which makes it, limiting reactant, and now it's no more in excess. Is this understandable to all of you? Yes, and if you want to prove this, you can do it like this. For example, we have identified that uh, the final mass of benzoic acid decreases. Now, how we will? So that's what it's the final mass of benzoic acid would going to decrease. See how. If you see, what is the MR of methyl benzoate? 136, right? Let's calculate the moles of methyl benzoate, right? Moles of methyl benzoate. So how much mass of methyl benzoate we have used? 1.242 gram, right? So moles of methyl benzoate is 1.242 over its volume 136 over its MR. Can anyone calculate it and tell me the moles? Yes, please. Can anyone? It's 9.31 when we are putting it in a three significant figures. Exponent minus 3. Maham, what calculation you did? Abdullah, you check your 1.10 is wrong, lesser. Maham, you again calculated. So we got the moles of methyl benzoate. Now calculate the moles of sodium hydroxide in this concentration. So whenever we need to find the moles with the concentration, so what we do, we multiply the concentration with the volume, and that volume must be in decimeter cube. So it is going to be 0.1, and 0.1 times 0.1 is going to be 1.00 exponent minus 3. Yes, yes, Abdullah. See over here, read this statement. Yes, it's 9.13, not 31. Okay. Now, if you look over here, you got the equation. What is the mole ratio between methyl benzoate and sodium hydroxide? It's 1:1. So it means for these number of moles, we need exactly the same number of moles of sodium hydroxide, but the moles of sodium hydroxide are actually very low or very lesser than that. So see, from the calculation, you can able to understand yourself as well and state the statement properly. So I'm going to write now sodium hydroxide is limiting reactant because its moles are now lesser than moles of methyl benzoate, C6H5COOCH3. Is this understandable to all of you? Yes. D1, explain why it is necessary to reflex the mixture in step 5. Okay, why we do the reflex? Why we put the reflex setup? So it means we are going to heat it, and the purpose of heating is to increase the rate of reaction. Heating under reflex, or when we are putting the reflex, means that we actually preventing the loss of any substances which have a lower boiling points. So it is because the rate of reaction increases and avoid loss of any substance. You can write which has a low boiling point or which is volatile. 2. Explain why a naked flame is not used in step 5. So it's simple. They are organic compounds. So these are flammable substances used are flammable. 1 minute, Abdullah. Till here, is this understandable to all of you? You see, have a look over here. The reflex is this. Then you have a round bottom flask over here. You are heating from here. So when the liquid evaporates, any substance, so it comes here, and from here, the water is moving, which condenses these vapors, and as a result, the vapors drop back into the reaction mixture again. So that's how the heating under reflex avoids the uh, escaping of any reactant which has a lower boiling point. Okay. Now, explain the purpose of transferring the liquid in step 6. Okay, let's read the step 6 again. Fit condenser to make the reflex separator, reflex the reaction for 20 minutes. Allow the reaction mixture to cool and carefully pour liquid into the beaker. So see why we are carefully pouring the liquid into the beaker. We have put some anti-bumping granules in it. So to remove those anti-bumping granules. That's why we are separating in step 6. So to remove anti-bumping granules. Clear? Is this clear to all of you? Now, E1. Explain what the student should do to confirm that the mixture has been acidified in step 7. Okay. So that if it has been acidified, so there must be acid in it. So dip, sorry, blue litmus, it turns red. Or add small amount of any indicator, you can write like litmus indicator. Red color is shown because the acid shows the red color. Or any other indicator can also, you can write. Is this clear? Now, E2. Describe what you would expect to observe as the sodium benzoate mixture is acidified in step 7. Okay. So, see over here. Sodium benzoate, see, read this. Sodium benzoate is the salt formed, which is then acidified with hydrochloric acid to form benzoic acid. This is the benzoic acid, right? Yeah, litmus is a litmus solution. It's an indicator, right? Okay, so see, what is the state of this? Over here, they are aqueous. It's an aqueous and we are getting solid. So it means it's an insoluble. And if it's an insoluble, so then what we will observe? We will observe that the precipitates will form or precipitation occur, solid forms. But for solid, we always write precipitates. Is this understandable? Now, F, suggest why it is necessary to cool the mixture before filtering in step 9. Okay. If we are cooling the mixture, purify the benzoic acid by recrystallization from hot water, filter dry and record the mass. So in a hot water, it means that it gets dissolved, and when we allow it to cool, on cooling, its solubility decrease. So before filtering, if we are cooling it, it means that we are making it more of the benzoic acid to be precipitate out. So benzoic acid is less soluble in cold water. Okay, now pure benzoic acid has a melting point of 122 degrees Celsius. Okay. The product made by student one has a melting point of 119 degrees Celsius. It means it contains impurity. Because of impurity, the melting point gets lower and the boiling point always increases. The student suggests that melting point of the product was lower than expected because it contains some water. Explain what the student should do to ensure that the product no longer contain water. So if it's a water only, then what we will do? We will dry the precipitate simply. And how can we make sure that there is no water left? Dry the precipitate. And then reweigh until constant mass is recorded. So when you get the constant mass, then it means that all of the water has been removed. Is this clear to all of you? Now, H part 1, calculate the maximum mass of benzoic acid that can be found from 1.242 gram of methyl benzoate. Okay. So, see, these are the MR of these two. And if you look over here in the equation, there is a 1 mole of this substance and 1 mole of this substance. So the ratio between these two are going to be 1:1. Because if you see, 1 mole of this substance is forming 1 mole of this, and this 1 mole of product is being used over here, and it's a 1 mole and producing 1 mole of a benzoic acid. So the ratio between methyl benzoate and benzoic acid is 1:1. So it means that from one third, if I make the ratio methyl benzoate and benzoic acid, their mole ratio is 1:1, which means that 136 gram of methyl benzoate is going to produce 122 grams of benzoic acid. So if we have this much grams of methyl benzoate, then X grams of benzoic acid would form. If you calculate the value, it is going to be 1.2 times 122 over 136. Yes, can anyone calculate the answer? Okay, it's 1.11. Thank you, Hussein. Now, next part. Student 3 produces 0.825 gram of benzoic acid from 1.242 gram of methyl benzoate. Calculate the percentage yield of benzoic acid produced by student 3. So if you see, the student has been produced this much amount, but from the calculation, we get to know that this much amount of benzoic acid must be formed. That is the maximum mass. So the mass produced from the experiment and the expected maximum calculated mass multiply by 100, you will get the percentage. Can anyone calculate the percentage and tell me the answer, please? See, you guys must read the question carefully. Otherwise, what a student do? Take this mass and this mass in the denominator. That's make the calculation wrong and your answer wrong. So we got 78% yield. Is this clear to all of you? Okay. Now, question number 2. Pure water dissociates according to the equation shown. Okay. The equilibrium constant for this reaction is known as Kw, the ionic product of water, and they have given you the expression over here. Okay. At 25 degrees Celsius, Kw has a value of 1 exponent minus 14 mole square dm minus 6. Okay. The pH of pure water at 25 degrees Celsius is 7. See, that's what I have always tell you to be focused that these values are for 25 degrees Celsius. Because Mariam, if you see, this mass is of methyl benzoate. This mass is of not methan benzoic acid. Experimentally, this mass of benzoic acid is formed, but from the calculation, we got to know that in actual, this mass must be formed. So that is the total maximum mass of benzoic acid that can be formed that we have calculated. And practically this much is formed. So that's why we take these two values. This value cannot be taken because it's not the mass of benzoic acid. And they are asking you to calculate the percentage of benzoic acid, okay? Okay. Now, a student finds the pH of pure water at 35 degrees Celsius is 6.84. See, I think we did one kind of this kind of a question in paper 4 as well. The student investigates how the temperature affects the pH of water and determines the value of enthalpy change for the dissociation of water delta H. The student records the pH of pure water at different temperatures. A line of best fit from result of the student investigation is shown in figure 2.1. One thing, clear this concept at 25, if the pure water has a pH 7, so it means that at 25, below 7 is acid, above 7 is a base or alkali, and it's a neutral. That same goes for this one. That 6.84 is the pH of pure water at 35 degrees Celsius. So it means at 35 degrees Celsius, below 6.4 is acid, above 6.4 is base, and at 6.5 it's neutral. Okay. Okay, this is the graph they have given. Use figure 2.1 to calculate the hydrogen ion concentration of pure water at 45 degrees Celsius. Okay. So here we got the pH. Now have a look at 45 degrees Celsius. This is 45. So the pH we are getting is 6.70, right? So to find the concentration of hydrogen ions, ten raised to the power minus pH, which is 6.70. Can anyone calculate the concentration of hydrogen ions over here? Yes, 1.995. Is there any exponent, Hussein? Exponent minus 3. Now, pH is equals to minus log to the base 10 of 1.995. Exponent minus 3. Can anyone calculate it, please? Okay, so it is 1.99 exponent minus 7. So the hydrogen ion concentration is 1.99 exponent minus 7 mole per dm cube. Okay. Now, what they are saying, calculate the value of Kw for pure water at 45 degrees Celsius. So we know as it's a pure water, then the hydrogen ion concentration is equals to hydroxide ion concentration, because in pure water, both the ions are present. Okay, sorry. Yeah, take the minus log 10 of this. No, I think your answer is correct. It's 1.99 exponent minus 7 here. So Kw is going to be concentration of hydrogen ions time concentration of hydroxide ions. So it is going to be 1.99 exponent minus 7 whole square. Can anyone calculate it and tell me the answer? Yeah, okay, thank you. Sorry. We don't need to calculate the pH, we need to calculate the log, sorry. Hydrogen ion concentration, my bad. Yeah. Can anyone calculate the square of this concentration? It's 3.98 exponent minus 14. Okay. Now, state the relationship between Kw and temperature. So, at 25 degrees Celsius, if you recall, Kw is 1 exponent minus 14. So, at 45 degrees Celsius, it's 3.98 exponent minus 14. So, it means that they are directly proportional, right? One minute, Hassan. See over here. At 25 degrees Celsius, what is the value of Kw, Abdullah? 1 exponent minus 14. And at 45 degrees Celsius, we got 3.98. So the value gets bigger, right? And SNC over here, when water dissociates, the number of moles of hydrogen ions and hydroxide ion are in the same ratio. So if I got the concentration of hydrogen ions in pure water, so it means that same concentration is of hydroxide and are also present in the pure water. Is this clear? Okay. Now, the student determines Kw at a range of temperature. The results are shown in table 1.1. Okay. So you have to do it. Who is going to do it? And tell me the answers, please. First, this one, then this one. Okay. So you have to write in three significant figures and Kw to two decimal places. Okay. So the first one is 3.53 exponent minus 3. Okay. Then the next one, 3.41 exponent minus 3. Okay. Next, please. 3.30 exponent minus 3. Okay. 3.19 exponent minus 3. Next one, please. 3.09. So after 9, what is the number? Can you tell me, Mehveen? So you will round off to 3.10 because it's 5 or greater than 5, but then we will round off it off. Okay. So it is going to be 3.00 exponent minus 3. Next one. It's 2.92 exponent minus 3. Okay. Now the log Kw. And you have to answer it in two decimal places. Can anyone do it quickly? Yeah, that's what it is. Log Kw, whenever there is a simple log, it's log base 10 only. No, log base 10 and log is the same thing. Okay, minus 14.53. Next one. Minus 14.16. Are you sure? After 6, what is the number, Maheen? If it's C, yeah, it's 5 or greater than 5, then you have to round off this one. Next one. Minus 13.83. Next one. Minus 13.53. Next. Minus 13.26. Is the last two. Minus 12.84. No. Minus 12.96. And then minus 12.84. Okay. Now, plot a graph on the grid to show the relationship between log KW and 1/2 uses a cross to plot each group. Each data point, draw a best fit line. Circle the one point on the graph that you consider to be the most anomalous. Okay. So who is going to tell me the values? Okay, we were almost done. So it's 3.53 exponent minus 3 and minus 14.53. 3.53. 3.53 is this one. And 14.53. So 14.552, 14.53. This will be the point. Okay. Then next is 3.41 and 14.17. 3.41 and 14.17. So 14.17, 14.10, 14.6. So 14. 7 is going to be over here. Then it's 3.30 and 13.83. 3.30 and 13.83. Okay. 13.83 is this one. Okay. Then 3.19 and 13.53. 3.19. So 3.19 and 13.53. So 13.552, 13.53 is in the middle over here. Then next one is 3.10 and 13.26, 3.10 and 13.26. So 13.26 is this one. Okay. Then we have a 3.0 and 12.96, 3.0 and 12.96. So at 3.0, if you see 12.9 is over here, 12.96. Okay. Then after 3.0, we have 2.92. And on 2.92, 12.84. 2.92 and 12.84. 12.8 and 2.92. 12.84. Okay. So we got this. And what we need to do? Draw a line of best fit. Okay. So if I draw a line of best fit, oops, starting from here, yes, so we got the line of best fit, right? And if you see, it's very clear. This is the anomalous point. I have circled it. It's 1 hour 30 minutes, Abdullah. Or 1 hour 15 minutes. 1 hour 15 minutes, yeah. Okay, now, so just one reason to explain the anomalous point you have circled, assume that there was no error in determining KW. So, if there is a no error, no, it depends upon the marks. So it means if there is no error in KW, so it means this value is on x-axis, it's correct, but on y-axis, it is going to be over here. So it means that if it is going to be over here, the actual 1 over T must be high. So it's a reciprocal of a temperature. If the reciprocal of the temperature would be high, then what means that it is calculated at a lower temperature. Right now, they have mentioned that it is calculated at a 343, right? but in actual it is calculated at a lower than 343. Why we are saying lower than 343? Because if I move over here, so 1 over T, the reciprocal of temperature is being increased, which means that the actual temperature would be lower. So over here, I will write that it means the pH recorded is at lower temperature than 343 Kelvin. Okay, now use your graph to determine the gradient of the line of best fit. State the coordinates of both points you used in your calculation. These must be selected from your line of best fit. Okay, so let's select them. Okay, let me choose this coordinate. So if I choose this coordinate, it's 3.0 exponent minus 3, comma, it's 12.84. Okay, then choose this coordinate, for example. So it's 3.15 exponent minus 3, and on y-axis it's 13.7, right? Okay, don't choose this point, take another point, because it's the point that they have given us, right? Okay, oops. What about this point? It's 13.2 on on y-axis, and it is going to be 3.02 exponent minus 3. Okay, so we got the coordinates 3.02 exponent minus 3, 13.2, and 3.15 exponent minus 3 over 13.7. So 13.7 minus 13.2 divided by 3.15 exponent minus 3 minus 3.02 exponent minus 3. Yeah, I just ignore the minus. That's not an issue, okay? Can anyone calculate the value and tell me the answer, please? Only the minus gradient is showing. Can anyone calculate the value and tell me, please? Yes, can anyone tell me the value, please? No one has calculated the value? Yes. 159. Okay, Abdullah. Okay. So better to keep 158.72. Okay. Now, see the relationship between Kw and 1 over T is given by the equation. Log Kw is equals to enthalpy change over 2.303 times RT plus constant. Use the gradient in B5 to calculate the value for enthalpy change in kilojoule per mole for the dissociation of water if you are unable to determine the value of gradient in, okay. So, yeah, thank you, Mariam. So see, it's shown that this value that you have calculated, Abdullah, it's incorrect because this is not very much, the difference is so big. It is 3846.15. Okay. 3846.15. Okay. So if you see the gradient, if I take the units of gradient, so it isn't it? It's going to be log Kw divided by 1 over T. So it is actually going to be times T, isn't it? Because it is divided by 1 over T, so that T comes to the numerator. So they are asking you to calculate the value of enthalpy change. We just ignore the delta H, oh sorry, constant. So delta H is going to be minus log Kw. Let me write the T first, then 2.303 times R. So see, isn't it this becomes the gradient? So delta H is equals to minus, and the value of gradient is 3846.15 times 2.303 and times R is the general gas constant. Its value is 8.13. If you don't remember, you have a constant values over here. Okay, it's 8.31. So you will get the answer. Can anyone tell me the answer, please? Yes, can anyone calculate it and please tell me the answer? It's minus 73607. And in R, if you see it's joule. So it means the answer we got in the joules per mole, not kilojoules per mole. So I have to divide it with 1000. When I divide it with 1000, it is going to be 73.61 kilojoule per mole. Is this clear to all of you? Clear? Is this clear? Okay, so we are going to do a next paper. I'm not sure about tomorrow, but so probably we are going to do a class on Sunday. Let's see. But tomorrow, not sure. Okay. So see you everyone in the next class. And whatever queries you guys have, you can always WhatsApp me. Okay. So take care, everyone. Goodbye and Allah Hafiz.